What if the moon isn't just a dusty, lifeless rock that's a natural satellite to the Earth, only orbiting around 238,000 miles away from our home? But this can be used as a gas station for the future of colonizing other systems and colonizing other planets and colonizing just the universe itself. We can use this as a gas station to power up Earth. We can use ways to power up rockets in the future. And just what ways can be valuable for human life to just transform the moon into, a home, for science and research purposes, like building little mobile homes, building generators, building different types of things that we can just use on the lunar surface. So scientists have confirmed that there's actual water on the moon, but not just the rivers or oceans or streams, lakes that we are used to on Earth, but frozen water ice hidden in the dark, deep craters of the moon. This ice is a value and a game changer for how humans explore space. Let's talk about it. Welcome to the Chris Nation 4 YouTube channel. I'm your host, Chris. Welcome. Also, subscribe to the channel if you guys are brand new, and let's get started. So, let's take a deep dive into one of the biggest discoveries in modern astronomy, space science, and just the biology of how humans can use water ice on the moon. How can it be used for just the fuel, but also, most importantly, humans when we go back to the moon's surface, what ways can we transfer that and make drinking water? What do we need to build? Like desalination plants, we know how to process water, wastewater treatment plants, and just generators marked on the moon's surface. These are ways that we can develop a foundation for deep space travel, not just like interplanetary missions like going to Mars in the future as well, but also exploring other galaxies, exploring other exoplanets that we have never discovered before or we have discovered, but also survive on these planets. What ways can we learn how to survive based on their resources? We want to understand this on the moon, and also, most importantly, as in the past of years, going to Mars. So let's talk about it. So let's look at the geography of the moon. The moon is just a battered, crater covered surface that's been, you know, had a very deep history for the last 4.6 billion years. It's dry, gray, dusty. There's no rain, there's no precipitation at all. It's just dry. But NASA's Lunar Resonance Orbiter and India's Chandrayaan 1, launched in 2008 but also operated in 2009, revealed something incredible. Water molecules exist across the lunar surface, but also even more exciting, the large amounts of water ice that's trapped inside permanently shadow craters near the moon's north and south poles. However, these are areas of the moon's poles where the craters are so deep. And the deeper the craters are, the less exposed to the sunlight they're getting. So they are trapped in this pool of, permanent darkness, but also extreme colds, where they can plunge to negative hundreds of degrees. So let us answer this question. Where did all that water on the moon come from? Well, most likely came from the relentless asteroid impacts early on in its life. Well, there was a time period, the late heavy bombardment period, which existed from 4.1 to 3.8 billion years ago. This is a tumultuous time where also, not just a tumultuous time, but also set up the seeds for life on Earth. And also, not just on Earth, but other planets too. But also, did something to the moon that changed its reactions. Well, asteroids contain little traces of water molecules inside, its crust, basically. And as they bombard the Earth and also the moon, you know, water eventually pooled over thousands of years and then eventually kept growing as more asteroid impacts bombard the moon and the earth. That set up, you know, the streams that we see on the ancient moon. Also, chemical reactions have caused by the solar wind interacting with the soils on the moon as well. Also, the nitrogens and the hydrogens, the oxygens, hydrogen and oxygen, H2O makes water. And that's what happened. And that's what's inside of the lunar soils is hydrogen and oxygen and other traces of elements that form bonds basically. So, but most importantly, hydrogen and oxygen formed water, and that's where most of this water has been hiding, is under these deep craters where temperatures are far below zero, where sunlight can't penetrate it. So, how does combustion work in a rocket? So, when we mine the moon's surface, right, we're using things as hydrogen and the oxygen. So, rockets use hydrogen for the most part, but also they use liquid oxygen as well. So everything's in this liquid stage. So liquid hydrogen and liquid oxygen. So how is that used? Well, rockets use hydrogen and oxygen to create a thrust through a combustion reaction. So think of it this way as cars. Cars use liquid gasoline, basically ethanol. And there's pistons in an engine, right? And spark plugs, right? For gasoline powered vehicles. Um, and they go through a process of combustion. Combustion is heat, obviously. And and then these spark plugs, right? They spray a tiny bit of fuel, and then the piston goes up, and then squeezes the air molecules and the fuel molecules, and then they create heat basically as they go up, and then it goes down, sucks in air, and then comes up and it squeezes it, creates heat, and that's what helps the car propel forward. See, hydrogen acts as fuel while its oxygen serves as an oxidizer. When combined, they ignite and produce high pressure gases that propel the rocket upward. And the process is governed by Newton's laws of motion, where thrust is a result of a rapid expansion of gases pushing that rocket upward. The specific impulse, which is the ratio of the exhaust velocity to the mass flow rate, determines the efficiency of the rocket's thrust. So rockets can be classified into different types based on fuel and oxidizer they use, with liquid hydrogen and liquid oxygen being the most common mixtures that helps a rocket go, basically. So, like a car, the most type is obviously the fuel. So, and then the fuel, and then also air too. Air molecules as well, and they get squeezed together under high pressure and high heat. That helps the car propel forward. So, how is water going to be used for astronauts when they land on the surface, and how is it going to be used for survival? Well, yes, drinking water, oxygen for breathing, water for growing food, but and also radiation shielding when stored around habitats. That's why we build domes and other structures. Future missions under programs like Artemis, like we have Artemis 1 that already successfully launched without humans, around the Earth and around the moon. Artemis 2 is now delayed again due to a hydrogen leak in one of the O rings that caused the mission to be delayed from the 6th of March to now April. So, if everything goes right, hopefully by April. If not, it's a possibility that they're going to keep delaying it because of that same issue, and they're going to just have to bring the rocket um, back into the main center, where they're going to figure out where everything kind of went wrong and see why the hydrogen's not staying in the tank. Because I think it's most commonly it is the O ring that is um, not properly sealed from that's kind of where I kind of got it from. It's most likely yes, it's the O-ring, but also it's other um, openings that are not properly sealed right. So anyway, let's talk about the water basically. So we mine the water from the deep craters, right? But how we're gonna have it to make well drinking water? Well, here on Earth, we use wastewater treatment plants when we handle our business and all that stuff. It gets sent to a wastewater treatment plant where they clean it out and remove everything on the waste, and they separate it, the waste from the water, and the water goes through a special treatment, and that gets sent back to our households and apartments and other things. And also, we have things like desalinization plants where you know, we get it from the ocean, right? The ocean water goes through a specific system, same way, but also gets treated. It separates the salts and the bacteria and it gets all that gunk and stuff out of that and separates it. So now you have left is the water goes through different pipe systems and gets traveled through different systems of the building, and basically they get treated the same way as a regular wastewater treatment plant. But I think it does it more a complicated area because, like I said, there's a lot of things in salt water they need to remove to have clean water through a specific system when areas are around a beach area. So on the moon, we can build the same way. We can build wastewater treatment plants, but also we can build the desalinization plants. And we can also use the generators as well. We have generators that are powered by AI, which thank you to Elon Musk. Um, yeah, so he's proposing that we will have AI factories for slingshots and different other things. But when we have a specific base, right? AI powered generators, but also solar power, using solar panels to absorb the light. But when the light is absorbed from the sun, it's used as energy, and that can power the generators, power up the wastewater treatment plants and the desalinization plants as well. How we can mine all that water, we'll pipe it, and the pipes will divert into a specific tank, and then diverts it through another system of pipes where it gets sent to these buildings basically, and they get treated. And yeah, so that will be easy to consume, but it would just be in a different way because, like I said, well, constructed by the moon's gravity as well, because the moon's gravity is weaker. So we have to design these plants a certain way due to the commons of the gravity of the moon, basically. So yeah, it's not as easy as we think here on Earth, but we'll figure out ways that we can take all that water and we can, you know, make it safe for human consumption on the moon, basically. So, with all of that stuff aside, but let's just say this mission going to mine water ice on the moon, it is not as easy as you really think. You would go down to the deepest parts of the craters, right? Where temperatures get as far below as negative 200 degrees. And there's sides of the moon, right? On the day side, temperatures reach up to 240 degrees Fahrenheit, whereas on the night side, on the near side, gets down below as negative 200 degrees Fahrenheit. And obviously, astronauts do have to survive that, and also the ATVs and the rovers and all of these materials that you need to get have to withstand that, because also the moon doesn't have an atmosphere as well, so it can't regulate that temperature. That's why it has a massive temperature swing between the nighttime side and the daytime side. So yeah, advanced drilling systems, solar nuclear power resources, processing plants to extract and purify ice, all of that stuff is expensive. And how expensive, you may ask? Trillions, trillions of dollars. It's like building an oil refinery on another world. Expensive. Trillions of dollars. And how much resources that need to be brought and sent back, that's also costing a lot of money too. Because, like I said, giving stuff around, and like I said, there's only certain stuff that you only have to bring because also weight and how much stuff that needs to be rationed, basically. And that's why, like I said, this was a metric that was used for a long time, since the 1850s, since the Industrial Revolution was spreading worldwide. They use a metric system called tons. And no, that's not tons in TONS, but it's spelled TONNES. Tons. It's a part of a metric system. Basically, it's ways that we can rations between what materials, like how much materials that we need, like how much ammunition we need to bring, how much fuel do we need to bring, how much food we need to bring, and that's what we need to bring into this, you know, to a certain ally, but also going to the moon, going to Mars, how much stuff that you need to bring, you know. Also, let's set aside all of the cost, but also let's set aside what if something happened? Like if someone got sick, injured, or dying, uh, multiple things, right? Harmful exposure to radiation that will give you cancer. You know, if injuries are reported, if certain sicknesses get involved, it all comes down to, you know, resources coming back and forth and messaging too. Messaging is the hardest part when you're going to the moon, going to Mars. I mean, going to the moon, yes, communication is only 1.25 seconds there and back. And yes, that's a very big time delay. But what if it's going to Mars? Communications there and back is 20 minutes. And like I said, I already did the exercise in the last video where we talked about that the moon's 30 feet away if we shrunk the Earth down to a school-grown globe or a styrofoam ball. The moon will be 30 feet away. Mars is a mile away in that scale. In real life, going to the moon is 96 hours total. But the entire trip itself takes 10 days because you have to orbit the Earth and you have to orbit the moon. And Artemis 2 is going to be doing that. But again, they're delayed because of different issues with communications, but also, most importantly, the fuel leaks too. Liquid hydrogen is leaking out. I think it's because it's common. It's the O-ring it's not sealed properly. That's what's causing these delays. So now instead of March 6th, they're going to April, sometime in April, which, like I said, it's kind of a bummer. But like I said, it all has to come down to safety, basically. You can't have a fuel leak. That's a big no-no. And yeah. But yeah, like I said, it all comes down to money. It all comes down to the negatives and the cons. But yes, there is pros, but mostly when you're setting your sights on a big wild adventure to the lunar surface, but also going to Mars in the future as well, like I said, it's just so many challenges too, but money. But also, let's talk about just how we kind of divide things around, a certain area of the moon, basically, or going to Mars. Like I said, I'm not a politician or anything like that. Like if you look at to like Antarctica is split and divided into like different research stations by several different countries, right? And they're all split into like little triangular sections. Norway gets one side, the United States gets one side. I'm just using that as an example, but yeah. So like I said, each country will get a specific section to what their side is only used for research on. But also same thing on the moon too. Like you have to abide by what section that you're only allowed on, you know, United States, for example, like I said, you only stay there and you build whatever land you're building right here. But, and then other countries will divide up and they build whatever they want. And blah, 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 blah. You know, China is building nuclear reactors on the moon by the year 2030, but the US is going to compete against that. So yeah. So yeah, who knows? Because I'm not a politician or anyway, but it's basically how it's going to be played out too. If we send humans to the moon, but there's ways that, like I said, we have to abide by specific laws and areas, what we can build and what is allowed, but also abiding by treaties as well. Treaties, um, yeah, treaties, land usage treaties, and how we compete against other nations. So yeah, that's one big treaty. But also there's a specific other treaty about what can we bring back from the moon and Mars back to Earth, but also certain rules that you can't contaminate the you know the materials that you brought back too, because like I said, companies can get into a lot of trouble if there's a specific contamination that happens on a piece of evidence that you brought back from the moon or you go to Mars. And that's what they need to abide by, or like I said, they get into a lot of trouble and they can get sued. So yeah, in conclusion, will we ever use the water to build as resources when we get to the moon? Maybe yes. Will we ever expand and colonize the lunar surface, Mars, and beyond? Yes. But the con side is money, resource rations, politics, and different other things. It all plays a big role into just, you know, the missions itself. Artemis has spent so much time and money to just eventually just get to the moon. And we have other companies like SpaceX, like Elon Musk, saying that, said we want to build catapults, build AI rockets, and you know what ways that countries are going to be using this side of the moon for whatever they're going to be doing. And you said, well, that's why the space race still happens too. Remember, the space race, like I said, existed since 1957 when the Soviet Union launched Sputnik, and we were freaked out because how did Russia somehow become so advanced, even though, again, the USSR was communist, and well, we need to compete against, the USSR as a free market capitalist. So yeah, that's basically what I want to say. Thank you guys so much for watching. I'll see you guys in the next video. Goodbye.